My name is Chandra Bhat. I am the director for the Center for Transportation Research at the University of Texas at Austin. CTR is an interdisciplinary research body that draws from a multitude of different programs from the university and beyond. And our mantra is collaborate, innovate, educate. And what we're going to be talking about, we heard quite a bit of discussion about electricity grids, water, but also we heard a good bit about transportation in the previous panel when the mayors were talking. And this panel is going to be focused on transportation and within the context of transportation on the buzz that is out there, autonomous vehicles and technology. We have a set of people over here who have done a lot of work in this area. I personally work in the behavior side of things, how people might respond, but there are issues of technology, there are issues of infrastructure, there are issues related to behavior, and just a smorgasbord of different things. Mayor Leffingwell was talking about the population growth that's happening and that has happened over the years in Austin. And we in the transportation area have tried to use a toolbox of different strategies to manage traffic congestion. And we are excited by the prospect of a technology-based tool that's been there for a long time, but we're talking about a substantial leap, if you will, in technology that might help in the context of managing travel, managing traffic congestion, contributing to the economic vitality of our region, the social vibrancy of our region. So that's the excitement, but just to be sure, all our panelists are very well aware that the excitement is there, but we are under no misconception that it's going to be a panacea for all the ills out there. So there are challenges in the next few years that we will face as we move toward more and more of the embracing of technology. And so the point of this panel is to start discussing the excitement. What's the buzz about? What can this do for us? What are the challenges in terms of privacy, security, energy? There are so many different implications. So with that, let me introduce each one of the panel members. I also want to thank Jose Basiro at the University of Texas at Austin and Mark Ishak for helping us organize this. We're excited to be here. The one sitting to the left of me is Professor Mike Walton. He's a professor of civil engineering, and he also holds a joint academic appointment in the Lyndon Johnson School of Public Policy, and this Mike Walton is part of the Center for Transportation Research. And just to show that CTR has this interdisciplinary outreach, he is a member of the National Academy of Engineering, the highest honor that can be bestowed on an engineer. He has been involved in many different national level activities. He was appointed by the governor of Texas to chair the 2030 committee to deliberate the challenges in transportation, very well known in the field. We then have Peter Stone, who is an Alfred Sloan Research Fellow. He is a university distinguished teaching professor in the Department of Computer Science. And again, Peter is part of CTR. So this, talking to the interdisciplinary collaboration that we like to do at CTR. He is very well versed in artificial intelligence techniques, robotics, swarming kinds of techniques, and collective responsibility and collective communications. To the left of him is Stephen Dellenback, who is the director of the Intelligence Systems Department at Southwest Research Institute in San Antonio, Texas. He leads a multi-million-dollar effort focusing on intelligent vehicles, research and development, on connected vehicle and autonomous vehicles. And by the way, these two are quite different notions, and we might get into that as the panel discusses things. And he has fielded 8 different autonomous vehicle platforms along with assorted enabling technologies. So Steve, thank you. And finally, but not the least, we have JD Stanley, who is the Public Sector Chief Technology Officer for the Internet Business Solutions Group. And he champions cross-sector and cross-disciplinary disruptive innovations. And he is very well versed in applying ICT advances to complex operation environments. So with that, as a prelude, as an introduction, let me start with Steve. Steve, you have worked in this area of research and development for quite a bit of time. Can you give us an idea of what this buzz is about? I know this is, you have a very restricted amount of time, but why don't you kickstart the excitement and the challenges?
First of all, to set a little bit of context, I work at a research and development company. I don't have any product lines. I'm not trying to sell cars or sell widgets at the end of the day. So some of my comments are going to be fairly blunt and direct about some of the hype you hear from other folks. As Chandra indicated, we've actually developed 8 different autonomous vehicles, and we've learned a number of things from these platforms. We have very high-speed, 80-mile-an-hour, off-road type ATVs, all-terrain vehicles. We have a Class 8 truck, which is a 18-wheeler cab, if you will, traditional SUVs that you see on the roads, and then 5 other military platforms that we've automated. And obviously all of us listen to the news and we hear about the Google car and we hear what's coming on in CMU, and the futurists are talking about how autonomous vehicles are going to be here in 2017. One of the things they don't talk about, though, are maybe some of the current limitations of it. The whole field of autonomous vehicles and connected vehicles, there's tremendous benefit in safety, in potential fuel reduction, because if you can draft vehicles, the same thing as the NASCAR or bike riding concept, you can save a lot of energy in the following vehicles, letting the first vehicle break the air resistance down for you. Connected vehicles allow vehicles to communicate to each other so that if one vehicle is in an emergency situation, it can talk to vehicles around you. How many people in here have heard of the Google car? Anybody heard about that? They say it's going to be on the road in 2017. What's one of the things they fail to talk about? Anybody know about the cost? How much money does it cost to buy the hardware that's on the vehicle? It's well over $100,000. In this whole area of automated vehicles, we have a lot of hype in the industry. Remember, I'm part of the industry. I'm helping develop it, but the costs are still extreme in this domain, and so that's going to be a barrier as we move forward. We might have some technology ready, but there is some costs there. Another issue is vehicles like the Google vehicle and some others have to pre-map the road. Google's pre-mapped 4,000 miles of the highways in the United States, and I believe there's 2.2 or 2.4 million miles of highway. So it's a very restricted space that it can operate. I got to experience something really cool. How many people heard of Uber? Okay, interesting idea. I was in Washington, D.C. in June, and Carnegie Mellon had brought their autonomous vehicle to Washington, D.C., and Chairman Schuster, who's the head of the Transportation Infrastructure Committee in the U.S. Senate, was riding in the car, and the Uber vehicle got stuck. And the reason it got stuck is the taxi drivers, the automated vehicle got stuck, excuse me, because the local taxi drivers were protesting Uber, and what they were doing is they were driving around the Capitol, ignoring traffic signals, essentially blocking the road. Well, the automated vehicle came up to that blockage, and it sat there for over 30 minutes because it couldn't nose its way in. And where I'm driving this is that we're really good at 95 to 99% of the driving situations, but how many times do you have to become aggressive? If you're sitting on I-35, if you're a real polite driver, what happens? You get further and further behind. Everybody else keeps getting further ahead of you. And so this whole world of autonomous vehicles, how do you build in behaviors and how do you start mimicking humans is a real big issue in moving forward. So, more futuristic, where do we see these things going? If you're familiar with the National Highway and Transportation Safety Administration, NHTSA, they've defined multiple levels of autonomy. And what you're seeing is a lot of the higher-end luxury cars are having what we call level 2 and level 3 autonomy. They'll have lane departure systems. They'll have adaptive cruise control, different from a traditional cruise control that's set on a single speed, but actually you can set it at 75, and if the whole pack's going 75, that's fine, but if the pack slows down to 60, the vehicle will slow down automatically for you. There's a number of really interesting technology solutions. But in closing, the comment, and someone like Peter, who's also a computer scientist, probably could lay at night and think about these problems. Has anybody ever driven in a snowy environment here before? If you grew up in the north, what do they teach you if a deer runs out in front of you in winter? You hit it. You go over it. And if you think about that, and the reason you do that, because if you're on an icy road and you're going 60 miles an hour and a deer runs out in front of you and you take an evasive maneuver and there's a ditch on the side of the road, you're probably going to be upside down at the end of the day. It's better to hit the deer. So how do you teach your vehicle to do these type of operations? You know, if you go talk to people that are doing research in autonomous vehicles, they're worrying about, you know, how you drive down normal roadways. But there are a number of scenarios that are real-world scenarios that are still some inhibitors for this technology. Last comment is things like platoons. If you think about, you know, what could Austin do in this area? What can the area doing? If we could come up with technology lanes where we could put specialized vehicles and keep the everyday human driver out of them, we could do lots of interesting things with platoons so that you can reduce the amount of energy it takes to actually move the vehicle. Lots of interesting things we can talk about as we move on, but enough for an intro.
Thank you, Stephen. Let's move on to Professor Mike Walton. Mike, we have heard quite a bit about the robotics, the intelligence that needs to be instilled, if you will, in these driverless vehicles. How do they mimic drivers? How can they mimic drivers and do even better because they are automated, if you will? But let's talk a little bit also about the planning side of things. Technology has rapidly gone beyond the dream, even 5 years back, of what we would have thought it is right now. But on the other side, technology has to work with infrastructure, with what we have today, with the transportation patterns of people. Mike Walton chairs the Texas Technology Task Force. So what kinds of things are you talking in that workforce, in that task force? What are the challenges you see in bringing technology together with transportation?
Well, good morning. I'm delighted to be here and pleased to talk about a topic that is of interest to us all, quite frankly, and it's, we're absolutely assured that it'll be here sooner than we perhaps think. A lot of transition issues, as Steve pointed out, and as others will point out. When he was talking about platooning of vehicles, I'll tell you about an experience that we had when we demonstrated a fully automated highway system in 1997. It's outside of San Diego. It was in the HOV lane, high occupancy vehicle lane on I-5. And so all the vehicles were instrumented that were being deployed. We had platooning of vehicles. I think there were 8 passenger cars that were equipped to show how platooning could be done and the various maneuvers. We put the chair of the House Science Committee in the back seat of one of the first demonstrations of platooning. The headway between the vehicles, the spacing between vehicles, going, I think it was about 60 miles an hour or such, was not much more than, it was around 3 feet. I don't remember the exact number, but 2 to 3 feet. 60 miles an hour, 8 vehicles in a stream. There was someone sitting in the driver's seat, but he was instructed not to touch anything in case, or only in case of an emergency. And he was, of course, had his hands out the window, waving at the traffic going in the opposite direction. So we did the demonstration. The platooning worked terrific. It scared the hell out of George Brown. I mean, the fact was that we have issues like that Steve was alluding to that we still have to work through. The human factors aspect is a big element of it all. So we're talking about an area that's ripe with a lot of opportunities, but I do believe in my mind, in a way, that we will have advanced technology of a whole host of kinds. But this transition from where we are now to the next is kind of the interesting twist, and it does provide an opportunity for events. There will be accidents, there will be failures, and we have to be ready for that. But quite frankly, it's an exciting time. So the Texas Transportation Commission, a couple of years back, established a goal, if you will, to put Texas in a leadership position in technology and transportation. So they ask the question, what are the advancing technologies that will make a difference? What are the transformational changes that are likely to take place? I was asked to chair that committee to help bring together people from around the country who have experience, knowledge, and could share that experience with trying to define where should Texas aim, where should they put their emphasis and their momentum. JD was one of those. Cisco Systems has been actively engaged in Connected Cities program in urban areas. They have demonstrations of that in San Francisco, Seoul, and Amsterdam, among others. So JD has a lot of knowledge about advanced systems, and I particularly like one demonstration that he would do, showing your virtual assistant in the morning that helps you plan your schedule, your travel schedule, and so forth and so on. I'll not get into that. Steve was also engaged because Steve has been, as he demonstrated, very active in this area for a long time. Plus, we had many, many others. And it was not just in transportation technology, but wireless communication or advanced communication, social systems, if you will, the social media. So there was a wide range of interest. So the Technology Task Force and its deliberations over the course of a year, and I will say that there is a report that's available online, and if you contact me, I'll certainly let you know how to acquire that. It may be on CTR's website, as a matter of fact, so you can go to that website and pull it down. But it came out with a report based on its deliberations. We looked at various technologies, and I'll share that with you. We felt that for Texas to get ahead, it had to skip some of the intermediate steps that are going on now in other places. And that's important. There's work going on in Detroit and other places about the connected vehicle, vehicle-to-vehicle communication, vehicle-to-infrastructure, so forth and so on. That active demonstration is taking place in Ann Arbor and in some other locations as well. And the notion is, of course, to see if we can help identify problems in advance, allow vehicles to communicate with one another, to avoid accidents, and perhaps lead us toward our goal of zero fatalities on the transportation network. I know what that sounds like, but we're not the first to be talking about zero fatalities on the transportation network. Sweden has been an active advocate of that for many, many years. And of course, Minnesota and other states have the same goal, toward Vision Zero, or zero fatalities on the network. So if you think about avoiding crashes at intersections and so forth, and some of the work that Peter's been engaged in will help in that regard, and putting us years ahead. But we're still going to have those accidents. But is that the final solution? And it was the committee's deliberation. It said, probably not. It's a very important component. It's a transition stage that we must go through, but it may not be the final solution. So what is the final solution? Well, we don't really know. You know, forecasting is all about the future, so that's exciting right there. You know that you're going to make mistakes you won't be able to pick, but it's important that you keep that ball moving ahead. So after deliberations, it came up with driverless vehicles, self-driving vehicles, autonomous vehicles, whatever your pleasure might be. That we thought was a target that we should shoot for. And then therefore, we investigated all the various intermediate steps. We're in a process. This committee has just been reconvened, and I'll be back in touch with these gentlemen to set up the next stage of that task force. And the issue there, or the goal, one of the goals will be to develop a strategic plan for deployment of the technology that puts us in motion to look toward the future, this transformational technology and other technologies. There's a host of other technologies out there that we need to identify and leverage in terms of what the opportunities might be. For example, transit vehicles. We demonstrated again that you can have autonomous transit vehicles, and that demonstration in '97. Houston Metro was a participant. It worked out very well. There is a demonstration going on, or several demonstrations going on in Europe. where the autonomous vehicle that's being deployed and investigated is a public transport vehicle in urban areas. Wonderful opportunity. It's working out very well. There's a high probability of success and a lot of excitement about that. In that regard, I will mention why Europe. Europe has identified the driverless vehicle, the autonomous vehicle, as their future vision target as well. So while they recognize they have to do the intermediate steps, and there's a lot of issues, technical issues in that area, they have developed a vision that it is driverless vehicles, it is autonomous vehicles, and there's some intermediate steps. So all the vehicle manufacturers, all the OEMs, as they're referred to, are in the midst of developing their own autonomous vehicles. And I'll just mention, for you to think about, quite frankly, they're just an enormous number of issues there. For example, does that mean, as Chandra suggested, that the business model for buying a car or having access to an automobile will be different tomorrow than it is today? Will you have as many vehicles on the highway as we have, or the roadway system as we have today? What about the insurance companies? The insurance companies' business model changes. What about all the health care associated with emergency action and so forth, and trauma centers and so forth? When you add up the total cost of crashes, accidents, fatalities, injuries, it's an enormous number. So you begin to think about what the implications of this might be, not just for energy, but in all the various areas. It becomes a very interesting opportunity for us. So I'll stop there. Delighted to be here. These gentlemen will fill you in with much more information that you may be interested in, but I look forward to the discussion session.
So one of the common themes in what's been talked about so far is you have things coming together, technology, transportation. This has been going on for a long time, but we are moving into a different era where there needs to be collaboration and understanding between folks who work in the wireless networking area and human factors, human behavior, and JD works at that interface. He has done quite a bit of work on technology and cognitive behavior, but also has done some really interesting and fascinating work in the area of distributed computing. So JD, why don't you continue our discussion?
Great. And you may think of, it'd be great if Cisco had autonomous vehicles and we could sell those, because of course we're a revenue creating company. But what you'll find is through all the things we've talked about so far, I have had worked on both the public sector side, just general energies and city, those aspects. I worked on Pecan Street in the creation of that. Also though, as you look at, I've worked on the military side. So there's various views, and I'm also very open about the autonomous vehicle is a great opportunity for all of us in the future, including around energy and the storage and treating it as a database and trading those aspects and so forth. At the same point in time, there's always the human factor of this, and there's always the unknown. A good example is when we walked on stage, I sat here only because I was first, but I didn't know that there was that many seats, and so they sit in the middle. Those unpredictable elements that we live in this world, they're unpredictable. When you see someone bicycling and all of a sudden they wobble, we all get very nervous. Cars will not anticipate those anytime soon. And so when you think about that, what does that really mean? So a lot of the work we've done is some of the work that was referred to is we look at the vehicle as just really a node on the network. So you can do lots of research on Cisco. They talk pretty heavily about the Internet of Everything, which seems very immersive and very big. It's a $19 trillion market that we've identified for the world. It sounds very enormous at $1 trillion, but when you look at the facts of that, there's really only 10% of the world that's connected today, of devices, of vehicles, and so forth. So if there's only that amount connected, what does that really mean? Well, there's a lot more potential of networking things, and there's lots of work going on in that aspect. But it's really not about the network connection. What it is about the services that you put around those. So even in the military days, we took things that are flying around now doing the UAVs and also even just airplanes, and we looked at those as they're a node on the network that is actually a provider of services. And what kind of services could they provide? It's not a silo. What you find, the IT industry for the last 30, 40 years have really built things to be inherited silos. We force you to click on a certain way in an app. We force you to take a different direction. The autonomous vehicle is kind of forcing you to say you must take the toll road and you must pay the toll and you can only go 50 miles per hour. We as humans cognitively don't think that way. Our behaviors are very different. We can be programmed sometimes, but many times we have to break those programs or we have to unanticipate that. Say, I really don't like this. I'm sure many of you are starting to get a little bit of overload of your iPhones, iPads, Samsung devices and saying, boy, I get the news, I check the news every 15 minutes, but I'm getting a little bored. I've checked my 10 sites and now I don't see anything new anymore. I'm getting a little bored. The games I play, it's a little boring. And so some of that human element that we've been absorbed into this digital world is starting to reapproach itself to say, well, there is something different just because of the nature we are, especially when you think about the analysis parts of this. So for the last year, I've been in an incubation program inside Cisco to create an analytics model based on everything we have. When you look at that, Cisco has many, many thousands, if not millions of nodes that we connect to, an installed base of $190 billion out there over those years. And so everything's connected. But when you look at the data flow, it's not so much about the individual data silos, it's about the trends and the flows of those, the ebbs and flows. You think about the old days 70 years ago about time and motion studies about how someone's doing manufacturing floor. Very methodical, very manual, very spreadsheet, draw it out. We're moving to a world where I can take the old time and motion studies and move those into a digital realm and apply those to make sure a node, an autonomous vehicle, actually is a service provider in its own self. And so what Cisco's created is fog technology that does policy basically enforcement or policy modulation at the edge. You can look at research around fog, but in essence, that's moving computation out in distributed environments. We've connected vehicles, but the cost of connectivity down at the vehicle, I've worked with most of the automotives, it's really high. It said that the equipment cost to do the types of things we're doing at the bandwidths we're doing, it sounds good on paper, sounds good as press releases, but the complications are extremely high because of the cost of the material to do that. And then you look at smart grids. Most of you have probably played in smart grids, worked in smart grids, experts in smart grids. When we first did urban planning, we looked at energy itself is extremely critical to our lives, but to some extent, home automation, once I've automated that first part and saved my $60 a month, I get bored with it. I move on. I don't want to even think about it anymore. You can't even probably tell me how to improve that extra $10 because it doesn't matter as much in the grand scheme of the rest of my life. Same thing with an autonomous vehicle. It's only one part of my life as a human, so you have to take the abstract part out of this and say, that's great for that moment in time, but what else could I do around that? And that's where what we see is this next generation of intrinsic analytics approaching, when you actually try to anticipate the services that you can either derive from. And I'll give you an example. I was a CTO, Cisco had donated to a nonprofit called the Planetary Skin Institute. I was a co-founder of that, and in essence, we did things around the world using satellite data and information systems with INPE, a space agency in Brazil. We helped create Semiden, which is a kind of a FEMA-like organization in Brazil, and we did this with NASA and the Department of Energy. What you'll find is inside that, there's two things I want to leave with you with. One was when we first started, we used satellites as a way to abstract out signal data to do reflectance about the changes in nature. So deforestation versus floods, those aspects. And it was a great little, hey, I baselined some data. This is kind of cool. I can see something in reflection that today is not covered in other type of data. Great algorithm. University of Minnesota did that. Good work. Okay. Now, what can I do with it? And what you find is that first 5 layers of data we launched 4 years ago turned into 2,000 sets of data geospatially. Why? Because of comparative analysis. Just taking one data set, comparing it to another data set, and someone with context, usually typically different people with different disciplines, a cross-discipline part, look at that and say, aha moments occur. Oh, can you do this? One of the most powerful tools we had was opacity. You may think that's simple in Photoshop or in Google Maps and what people do today, but opacity was one way to look at one colored image versus a different colored image, and you start to see the connection between those. And that's where you start to see that the human part of this that comes out. So one is looking at a node on the network, treating that as a service, but looking at the data as a lens of different perspectives. I'll give you the other example of this, is something that is noise to one. Good example is when, and maybe some of you know this, but attenuation is something that happens in surface fire environments. When 2 cell towers and it rains, there's a disruption in signal. Of course, you as a consumer hate that your signal is weak. The service provider hates that because they boost the energy. Of course, all of you producing energy, making money off that, love that because they're producing the energy of the cell. But what's happening is that's noise to a service provider. They really don't like it because the physical disruption of the wave is causing a decrease in the cellular service, which then does not help their customer behavior. Hey, I want more people using it. I don't want to disrupt that connection. On the flip side of that, if you remember a few years ago, there was lots of deaths in Rio because of landslides. Well, those landslides were caused because of saturation of soil. Lots of people try to do advanced modeling of saturation of soil, but they need rain as an input into that, so that way it's not so assumption-based. Most analytics have a lot of error-based, human-based assumptions, and so people overplay what the analytics is because of the modeling nature. So when you look at this, and I tell you the actuation, what you'll find is the rain coming through the two antennas is a higher predictor of the volume of rain in that 15 minutes than a rain gauge or weather radar. That is a great input, a higher fidelity input into the analysis that actually allows you to look at soil saturation rates, improving the quality of the model and improving the ability to save lives. That's work that we worked on a few years ago. So it gives you a sense of that something is noise to one. So think of what Google's thinking about, that maybe the business model is they want to sell you. They want everything about to know what radio station you listen to, what behavior you drive in, you know, what type of things you're searching on the web, what kind of commerce you're doing as you're in that vehicle, and they control you, right, as it goes through them. They won't necessarily control you, but as they control that experience. Where that, to them, something that they also don't see is the cellular tower information or the mobile telecom data that comes from a service provider, who might actually be a better predictor that a human's going to walk off the curb than actually Google will identify through the radar. And it just gives you is what noise is to one is gold to someone else with the right context. And so the cross-discipline nature is very important. We originally for Seoul built this personal travel assistant, which was basically a virtual Siri at the time. We built it to where we linked in bicycling with walking, with cars and public transportation to help people start to get a route. Now, of course, others have come up with that as a more productionized service. But my number one learning is that as a human, I'm sorry, you can't predict what I do. I'm one of those people who log out of Amazon after I order something. I'm one of those people who actually have my cellular phone turned off because I know I can track you in Nordstrom's if your Wi-Fi is turned on. So there's all kinds of things that are noise to others, but can be gold in the right situation of analysis. And energy mixed with autonomous vehicles, if the vehicle connected is a good data source of data, then that in itself is good for the provider of that vehicle, but it also could be good because the things they think are noise are good for others. But in this matrix that we're all living in, that's just one source of data. So how do you find the intersections, the novel linkages, those aha moments between the other sources that help you provide the value of a service? And that's something similar we told TxDOT. What is a service you're going to provide? How can you improve the experience of the transportation individual in transportation? And then how can the private sector help improve additional services around that? Think about how they could partner with Target, with a service provider, and with the autonomous vehicle folks to create a different type of service in that cross-discipline than the individual TxDOT could do on their own. And that gives you a sense of what you're looking at is the business models, as we discussed, are changing. The human behavior is unpredictable. It's great tech. I love it myself. I don't know if I'll drive in it, but I'd love to have a telepresence unit in there and have my telepresence with Europe as I'm driving. Bandwidth's not there yet, but it shows that it could help improve my quality of life, but it's only one part of my life. What else is part of that? Energy is a good example too. It's only one part of that life. And so I'll leave you with that.
So JD, you alluded to the idea of fusing information from multiple sources to create much more value. We humans, though we are error-prone in many different contexts, we are reasonably good information processors. We do absorb audio cues, video cues as we drive. We put it all together. When we see a school bus out there, we know that it's going to stop near railroad crossings. You know, this transitions into, Peter, some of your work. Where are we in the artificial intelligence field? Where are we in the robotics field, where machines are able to absorb some of the capabilities that we humans actually have? We are error-prone, yes, but we are pretty good information processors also. Where are we in that field?
Sure. So first of all, thanks, Chandra, for organizing the panel, and for all of you for being here. It's an honor to be here. I'm the one standing between you and the discussion. I'm sure there's many comments and questions that you have, so I'm going to try to keep it brief and make two main points. The first is, I've been on panels like this before, and it's never interesting if everybody just agrees. So I'm going to disagree with something some of the, and maybe to do that I'll have to put a little extreme view on what Steve said. But Steve was telling us to slow down and be wary of the hype, and that people are saying, oh, autonomous vehicles are here, but there's challenges. And yes, there are definitely challenges, and we've heard not just from Steve, but the human factors issues and the insurance companies and the what are you going to do when there's a deer and it's snowing. And I would like to sort of take the opposite view. I think actually the technology is there. It's going to be within the cost limit soon, and we all are going to be driving in autonomous vehicles before long. And part of that is because of what Chandra is alluding to. People are pretty good at doing the right thing. And most of us, perhaps, if we saw a deer and we were driving in snow, would run over the deer. But the reason that this is brought up as an example is many people don't. And people do end up in ditches and upside down. And the fact is that the autonomous cars are not going to be perfect, and as Mike said, there will be accidents. And it'll always be possible to come up with cases where people are better drivers than the cars are. At the same time, there are going to be many situations where the cars are better drivers and make better decisions than the people do. And that's true of, computers are never going to be people, and that's the sort of the AI view. Computers and robots it's better to think of them as a different species. Right? People always ask, oh, when are computers going to be as intelligent as people? It's been a long time that many, many years since I would want to get into a multiplication contest with a computer. Right? There's things that computers are better at, and there's things that robots will be better at. And there will always probably be things that people are better at. The fact is, I had an autonomous car in the DARPA Urban Challenge in 2007, and it was already capable of driving and on roads and handling stop signs and passing traffic, passing stopped cars appropriately, doing most of the things correctly. It wasn't perfect. At the same time, I right now have a 16-year-old daughter who drives, and she does most of the things well as well. But I've also seen her almost get into accidents, and there's many times when I think I would actually rather drive past my autonomous car than I would drive past her on the road. And but yet, we give licenses to pretty much every 16-year-old. So in some sense, driving is very easy. And the example of the deer, it's not hard to give an autonomous car a rule that says if it's snowing and there's a deer, don't evade. The hard part is the perception that Chandra was alluding to. People are very good at the deer darts out. We can instantly say, oh, that's a deer. That wasn't a little boy. Right? If it's a little boy that jumps out in front of the car, yes, you do want to take the evasive maneuver, even if you're going to end up upside down in the ditch. Right? So it's this perception aspect that is a challenge, that remains a challenge, and yet there is a lot of progress in the field of automated vision and artificial intelligence that is getting very good at recognizing the difference between a deer and a person. And even a ball that is likely to have a little boy running out behind the ball. So I guess the where I'm going is that I think the pessimism about the difficulty of driving, I think is sometimes overstated. In fact, I would go the other way, is that it's not going to be very long before autonomous vehicles are everywhere, because of the huge advantages. And there's the obvious advantages of people who can't currently drive will be able to be mobile. The elderly, the blind. From my perspective, it would be great not to have to drive my kids to soccer practice every day. But there's also, the theme of the day is energy, and there's going to be huge energy savings by enabling car sharing, people changing behaviors, and also allowing, well, I'll foreshadow that I think there can be huge energy savings also in the way that the whole world will change, in the way that JD was saying, it's just going to be one part. And so I said the first point I wanted to make is that I'm going to take the view that autonomous vehicles are going to be here quickly. The second point that I want to make is that I think people in general are not grasping what the full implications are going to be. And it's not going to be, I think, in the same way that when the microwave oven was invented, it was very easy to just think that it was going to be just like a normal oven, but quicker. But that's not what it was. It changed people's eating habits. There are whole aisles in grocery stores devoted to microwave food now, right? It changed sort of lifestyles. The cell phone, it was very easy to think of it as just going to be like a corded, tethered phone, but now you could walk around. But that's not the case. It changed the way you meet people when you go out to lunch or to a concert. It changed the way, whether you print directions. It changed a whole bunch of habits. And I think that's going to be the case with autonomous vehicles as well. It's tempting to envision that you'll just be sitting in your car and all the rest of the cars will be driven by people and traffic will look just like it does today. But that's not going to be the case. Once there's one autonomous car, all the cars, or many of the cars on the road, are going to be autonomous. And there's opportunities. One of the studies that I've been deeply engaged in is rethinking what will intersections look like when all the cars on the road are autonomous. Will we still use traffic signals and stop signs, which are great mechanisms for people, or can we take advantage of the unique capabilities, the different capabilities of autonomous cars, which will be much more precise driving and the ability to communicate with the infrastructure, to allow a mechanism where cars call ahead, reserve a time slot through the intersection, and barely have to slow down. So we've had a video where sort of the cars are approaching the intersection, and they slow down a little bit and they change, but they basically all go through, sort of like if you've seen the Jetsons. It's sort of they're just an intersection where they all go right through. You don't have to have a traffic signal. You don't have to have a stop sign. Autonomous vehicles will be able to do that. That will reduce congestion. That will reduce energy usage because a lot of the energy is used up by accelerating and decelerating. And so I think other concepts we've explored is with autonomous cars you'll be able to have dynamically changing directionality of lanes. It would be very confusing to a human driver if we told you, right now there's 3 lanes going one direction and 1 going the other direction. That can be done sort of on a morning time, nighttime basis. But if we did that on a minute-to-minute basis, there would be chaos with human drivers. With autonomous cars, you just have to send a signal, and they know now it's 3 lanes in one way, or now it's 2 lanes in each direction. And that'll help be able to adjust to congestion conditions. Land use will change because if cars are autonomous, do you still need parking lots downtown? Probably not, right? The car can drop you off and and then come pick you up later. Or you don't even own the car, there's car sharing. There's all kinds of ways in which the world's going to change that I think we need to start envisioning because there's some preparation that's needed. And it's in terms of what infrastructure should we put at the intersections and how should we start re-envisioning the values of lands and how should we start change reapportioning land. So I'm gonna leave it there with those the 2 points I think the autonomous cars are coming sooner than you think. And that I think that it's still sort of surprising and unanticipated ways in which they're really going to change our lives in a very paradigm-shifting kind of way.
I'm just going to make a couple of comments just to keep the excitement going. I have a different perspective from what you just heard. In a lot of ways, I think we're talking about behaviors changing, and you alluded to that. And certainly, there's this possibility of having no garages, or at least much fewer garages, and that reduces idling, going around in circles in a garage. Certainly, that could be energy savings. It certainly helps in terms of providing mobility to those who are physically challenged. A lot of benefits. One of the things that I work on is how might behavior change in terms of travel patterns. And the other side of it is potentially time is not an issue anymore, right? So I'm going to start living in the boonies. I'm going to be commute 60 miles. Why do I care about it? I'm just going to be in my autonomous vehicle. I'm going to be sleeping. I'm going to be working. I can do a whole host of things. So there's, on the other side, there could be an offsetting behavior where you have cities becoming much more sprawled, so to say, and that can contribute to vehicle miles of travel. Potentially, there is this possibility of people wanting to own larger cars because they're spending more time in their cars. The extreme case would be each one of us wants to have a recreational vehicle for travel. So I'm not disagreeing with what you just mentioned, Peter, but I think the uncertainties is what the excitement is about. And there's lots of potential positives, lots of possibilities of how there might be offsetting behavior, and part of what we are trying to do as a community, as an interdisciplinary community, is to try to have a robust planning process to move forward. So anyway, we have about 5 to 8 minutes. Are there any comments from the audience to the panelists?
Can you discuss is there a relationship between the type of propulsion system of the car? Basically, let's say, propulsion systems could be either fuel-fed internal combustion or diesel engine on one hand, or battery or other energy storage electric vehicle, where the vehicle is being moved by an electric motor, an electric drive system. Is there a relationship between the choice of propulsion system and the possibility of the autonomous vehicle? And specifically, is an electric drive inherently more amenable toward automation than internal combustion engine?
Well, yeah, and I think taking some of the things that Peter works on a daily basis, because if you considered you had autonomous fleets and you were doing car sharing so that maybe people didn't own vehicles, you could then have a master planning algorithm that said, okay, this vehicle's traveled 67 miles, it needs to go recharge, you can't dispatch it to the next location. And so from a technology of the autonomous vehicles, the direct technology, no. I think for the practical implementation of how you could deploy it in society, there's a very strong connection, because it would be how you could utilize the assets you have within the power constraints in what you do. So I can see a lot of value in that.
It's probably in the electrical, it's much more of a stronger platform to actually grow into these type of services. I was thinking of dating, fast lane, right? So all the signals get in the one lane and they can communicate between their vehicles even. So when you think about those things, it's much more viable in the electric vehicles for those type of future platforms. Even if the costs are higher now, in the future, that's not, as Peter said, that's not the case. And so it's much more about what you can do with it and not have it. It's more like in routing and switching, having a big router that has a virtual machine on it. I can do so many more things now than I could, 20 years ago, when it was just very siloed and very specific.
I think another response might be that all the manufacturers are playing with different power sources, energy sources. So you're going to see both in the intermediate stage. And of course, battery technology has a lot to do with that. Interesting that a lot of the vehicles that you see and the autonomous vehicle images and so forth, the visual representation is a very small vehicle. And if you look at the Google vehicle, for example, it's limited in what it can do, but they're planning not to have a steering wheel, not to have an accelerator, not to have a brake. So you're in this small compartment. That lends itself to an electric vehicle, I think.
I'm a recovering communications engineer, so it's fascinating to listen what Dr. Stone was talking about relative to what's described a TDM system, and I'm thinking of Mr. Stanley over there kind of trying to apply that to a carrier sense multi-access, but you got that problem with collision detection, right, and versus collision avoidance on those algorithms. But stepping away from that and going maybe to a higher policy issue, and again using a communications analogy, we have kind of two worlds today. We have a multi-point world or a mesh world, pick whatever analogy or metaphor you want to use relative to that, which is autonomous and non-autonomous vehicles, individualized vehicles. And then you have point-to-point systems. And I'm just wondering from a policy perspective, are point-to-point systems, i.e. light rail trains, metro rail trains, et cetera, are they in effect the mini computers of transportation technology today? And the reason I use mini computers is fascinating what mini computers, in my opinion, were dead before they ever got started, because, and I can't remember who was talking about punch cards, et cetera. I came up in the punch card world in '78. The first Apple II came out in '77. The first DEC VAX came out in '76. And in effect, the mini computer, this whole concept of a small time-shared unit, was basically obsolete before it ever got started, but yet inertia carried it with prime computer, DEC, et cetera, for 10 to 15 years. I'm just wondering if you have an opinion on whether investing now in what I will call point-to-point transportation systems or fixed transportation systems is basically investing behind the curve and is money wasted.
So,
Mike, you want
The previous panel wasn't.
Peter and Mike?
I would comment, first of all, it's very tempting to make analogies between physical transportation and network packet routing. And we've tried to think of things in those terms. I'm in a computer science department, that's only natural. But my experience has been that they're actually a lot more different than you would think, and that it's sort of at your peril that you try to think of a transportation network like a packet switch network. The physical space of getting through an intersection or getting through the network and the congestion that you have behaves very, very differently than sort of, than network packets. With regards to, it seems like you're suggesting that maybe public transport and sort of point-to-point is may not have a role once there are autonomous cars. I don't think that's the case. I think there are ways that you will be able to do public transport more. In some sense, maybe all transport will be public if it becomes a car-sharing world, but the point-to-point aspect of it, I think you can do much better once we have more information. So I do have colleagues who are working on sort of on-demand bus scheduling, rather than having a sort of fixed schedule. If people are calling into the system of where they want to be, when they want to be picked up and where they want to go, it can still be point-to-point, but you can be much more intelligent about how you schedule the buses and possibly even the routes that they take if you know nobody's going to need a stop or something. I think there's still going to be these sort of economies of scale on well-traveled routes. If there's the reason for point-to-point is when you have a lot of people that are going to go from one place to another, it's worth investing in the more efficient way of getting them there. And then when so I think we have to think of sort of the whole mix of trips that people take. And I think if you notice, if you look at it, you'll see there's some backbones and there's some sort of arteries, and the arteries are where you'll need the mesh, and the backbone is the economies of scale are still going to be operable when it's autonomous vehicles doing it.
Well, the only question I'd want to ask relative to that, again, taking this theory that investing in these heavy, big infrastructure, big public project type of projects, is investing behind the curve, is the whole value of what I'll call laminar flow. I know traffic engineers think a lot about laminar flow and how you do that. And one problem you don't have with a fixed point-to-point system is laminar flow, because you know the traffic, you know what's going on. Other than a train delay or breakdown, you have perfect laminar flow. Doesn't the autonomous vehicle solve that problem and again make make these thick point-to-point routes obsolete?
It depends whether it's also tempting to think that once you have autonomous cars that you'll know where everybody's going to go and you'll have a centralized system controlling all of them. I don't think that's the way it's going to be. People aren't going to accept a system that when you get in the car, somebody else from the center of the city tells your car exactly where to go. People will accept incentives in terms of tolls or in terms of information about which routes are more congested now or later, but I think even when the cars are autonomous, there's going to be a concept of the individual car maximizing its own self-interest. And so when you have that, there's still this unpredictability of traffic, and I think we're always going to have to live with that. We can get better analytics and better predictions about it, but I think it's not going to go away.
Last words then.
Yeah, quick comment on that. The analogy of communication and transportation. We used to think that communication could be a viable substitute for transportation. What have we found out? It's complementary. So therefore, I would think that the line haul systems that you're suggesting, or point-to-point, will be in the many-to-many distribution systems, will be complementary more than a substitute.
Stephen, any additional thoughts?
I was just saying, from a policy perspective, the big challenge we have now is cities can't afford $6 billion investments, or states even. So now what you need to do is figure out, if you're still investing in the big, how do you actually chunk that up so it's handleable, so you can iterate. It's just like the old days of ERP. People tried to do ERP projects that took 5, 6, 7 years and never got anything out of them, except for more nightmares. And we've moved into much more of an iterative process. And it's the policy level, it's the combination of the energy mixed with the transportation, mixed with the autonomous, and doing it in a way that's a policy that's more manageable within years, not decades. And that's the big challenge for a public sector and policy is doing these things in decades, as we saw in TxDOT 2020. You can't predict out to 2020. You know how much change is going to occur, even behaviors to technology. Maybe that rail line won't disappear, but so many other factors impact those lane lines and railways. And so it's a portfolio, but doing it in a way that's chunked into years, not decades. That's the big challenge for policy.
And one of the things that's been mentioned is that even if you have autonomous vehicles, these vehicles are going to be self-interested entities. And that's really because there are people who are going to decide where they want to go and how they want to participate in different activities. So it's an interesting time where we have human behavior coming together with all these technological advances and infrastructure. Exciting time, and what we are trying to do is trying to come up with scenarios of how the future will evolve on many, many different fronts. So, but thank you so much to all the panelists. Appreciate your participation. We are at 12. I was told that we had to end exactly at 12, which we are doing. Thank you so much for being here.